All right, let's dive into the incredible physical geography of India. It's a place that's so diverse, it's practically a world in itself. And to help us explore it all, I've got a student here who's full of some really sharp questions. You ready to get started?
I am. So I was looking at a map of India the other day, and it just hit me. How is it so impossibly diverse? I mean, you've got the towering Himalayas, the Thar Desert, these huge flat plains, and then tropical beaches, all in one country. How does that even happen? It really is like a whole continent crammed into one subcontinent.
That is the perfect question to kick things off. And the answer? Well, it's a story that's been written over millions upon millions of years. Think of it like an epic tale, starring colliding continents, powerful rivers that literally build land, and the slow, relentless force of erosion.
So to really get how India's geography came to be, we're going to explore its 6 major physical regions, one by one. We'll look at how they were formed, how they all interact, and how they work together to create the world-famous Indian monsoon. It's going to be quite a journey.
So, let's start with the big picture. Geographers break India down into 6 distinct physical regions. And trust me, each one has its own completely unique backstory.
We've got the sky-high Himalayas, the massive northern plains, the ancient peninsular plateau, the dry Thar Desert, the green coastal plains, and of course, the islands.
Wow, that is an incredible amount of variety for just one country. What kind of geological forces could create such dramatically different landscapes right next to each other?
And that's where the story gets really dramatic. You see, the whole geography of modern India pretty much begins with a massive, world-changing event, the collision of 2 continents. This is the force that created the Himalayas, the tallest and, mightiest mountains on the entire planet.
Right, the Himalayas are by far the tallest mountains we have. So what kind of geological force is powerful enough to create something on that scale?
Okay, imagine 2 cars in a super slow-motion crash, but on a planetary scale that lasts for millions of years. That's pretty much what happened. The Indian tectonic plate was drifting north and just slammed into the much bigger Eurasian plate. All the land caught in between had nowhere to go but up. It buckled, it folded, and it rose into the sky, creating what we now call the Himalayas. And get this, geologically speaking, they're actually some of the youngest mountains on Earth.
This massive collision actually created 3 distinct parallel ranges of mountains. Farthest north, you have the Himadri, or the Greater Himalayas. These are the absolute giants. We're talking peaks like Mount Everest. South of them, you get the Himachal, or Lesser Himalayas, which is famous for all its beautiful hill stations. And finally, you have the Shivaliks, which are basically the outer foothills, made from all the rock and debris that's washed down from the still rising mountains above them.
Now, what's really cool is how the creation of the Himalayas had this huge ripple effect across the whole subcontinent. The incredible weight of these new mountains literally pressed down on the Earth's crust, creating a giant depression to the south, a depression that would eventually become the incredibly fertile northern plains.
Okay, so the Himalayas created a sort of basin just south of them. But how did that huge basin turn into the northern plains, which is one of the most fertile and populated places on the entire globe?
The secret is in the rivers that flow out of the Himalayas. For millions of years, the Indus, the Ganges, and the Brahmaputra rivers have been grinding down the mountains and carrying tons and tons of nutrient-rich silt, what we call alluvial soil, down into that basin. This constant depositing of soil created these massive, flat, and super fertile plains. It was the perfect setup for agriculture, and it basically turned the region into India's breadbasket.
So the north is all young, geologically active, and dramatic. But southern India feels completely different. It feels much older, more stable. Why is there such a huge contrast? You are spot on. The peninsular plateau, which makes up that big triangle of southern India, is the total opposite of the Himalayas. It's one of the oldest, most stable land masses on the planet, made of hard, ancient crystalline rocks. Think of things like granite. This plateau, which is split into the Central Highlands and the Deccan Plateau, is the original ancient heart of the Indian subcontinent. It's the very piece that did the colliding in the first place.
Okay, so we've got the young, active mountains up north and this ancient, stable heartland in the south. Now let's move out to the edges of the subcontinent, the deserts, the coasts, and the islands. Each one of these has its own unique story to tell.
Before we get to the water, I've got to ask about the Thar Desert. How on earth can you have a desert sitting right next to the super fertile northern plains? It just seems like a total contradiction.
It really all comes down to rain, or more specifically, the lack of it. The Thar Desert gets almost no rainfall. less than 15 centimeters a year. And that's because the Aravalli mountain range runs parallel to the monsoon winds. So instead of blocking the clouds and forcing them to drop their rain, the mountains just let them pass right on by, creating a dry, rain-shadow region.
And what about the coasts themselves? On a map, the west coast of India looks so different from the east coast. Why is that? That's an excellent observation. The western coast is narrow and pretty steep because it's basically the edge of a rift valley, which formed when a piece of the subcontinent broke away millions of years ago. The eastern coast, on the other hand, is much wider and flatter, and that's because it's been built up over centuries by the massive deltas of the major rivers that flow into the Bay of Bengal.
And the islands? Are the Andaman and Nicobar Islands the same kind of landform as the Lakshadweep Islands? Not even close. They couldn't be more different. As you can see here, the Andaman and Nicobar Islands over in the Bay of Bengal are volcanic. They're actually the peaks of a mountain chain that's mostly underwater. But the Lakshadweep Islands in the Arabian Sea? They're made of coral, built up very slowly over thousands of years by tiny little marine organisms.
Now, we absolutely can't talk about India's geography without zooming in on its rivers. They are the lifeblood of the country, for sure, and just like the land itself, there are two very different types of river systems.
So what's the big difference between the rivers coming from the Himalayas and the major rivers in the south, like the Godavari or the Krishna?
It all boils down to where they get their water. The Himalayan rivers are fed by melting glaciers and snow. That means they are perennial. They flow all year round. But the peninsular rivers, like the Godavari, Krishna, and Narmada, are almost totally rain-fed. Their flow is seasonal. They swell up during the monsoon and then shrink way down during the dry season.
And that brings us to the grand finale. We've seen how all these different landforms were created, but now let's see how that very same geography works together to create one of the most powerful and life-giving weather systems on the entire planet, the Indian monsoon.
Hang on a second. So you're saying the geography of India doesn't just put up with the monsoon, it actually creates it?
Exactly. The monsoon is like a giant weather engine, and India's geography provides all the key parts. In the summer, winds full of moisture from the Indian Ocean get pulled inland. The western Ghats Mountains act like a huge wall, forcing the Arabian Sea branch of the monsoon up, which makes it dump tons of rain on the west coast. Then, the Himalayas act as an even bigger barrier, stopping the winds from escaping north and steering them west across the plains, which waters the entire heartland of the country. So it's all connected. The Himalayas create the rivers and control the climate, the rivers build the plains, and the plains feed the country. It's all just one giant interconnected system. That's a fantastic way to put it. Every single part of India's geography plays a critical role. The Himalayas are the water towers, the plains are the breadbasket, the plateau is the mineral storehouse, and the coasts connect it all to the rest of the world.
So, the next time you look at any landscape, doesn't matter if it's a mountain, a coast, or just a simple valley, remember that it's not just a pretty view. It's a story that's been millions of years in the making. It really makes you wonder, what other incredible geological stories are out there waiting to be discovered, maybe even right in our own backyards?